So now we've got all of our routing protocols working. In the last section, we also implemented network address translation to get a little bit of hands-on practice with that. Now we're going to move into gateway redundancy, also known as first hop routing protocols or first hop router protocols, FHRPs. And one of those is the hot standby router protocol, HSRP, which is Cisco's proprietary way of doing this. So let's see how we can implement that in our topology. Okay, so now we're going to undo all that NAT stuff that we just did on R4. So if I go back, this is the configuration I worked up on R4 for NAT. Really, the only thing we have to do to undo it is just get rid of our interface commands. We can leave all the IPNAT inside, all the IPNAT pool, even the access lists, but if the interfaces don't have any NAT configuration, there isn't any NAT going on. So let's go ahead and just change this a little bit. But, to be on the safe side, I mean, it's not safe, but just to be clean, so we have a nice clean config, I'll go ahead and just strip all this stuff out. We can leave in that OSPF network. It's not going to hurt anything. Okay, so we should be back here without any NAT on this guy. Shut that down. Remove all PPP over Ethernet configuration from R2 and R4 and ensure both these devices can ping the IP addresses of switch 2. So we're reverting back to a regular Ethernet. Great. Let's get rid of that pesky virtual template. Okay, I'm still going to have to put my IP address back on that guy, but let's just make sure I've removed all of my PPPoE stuff. Looks good. Still got that IP local pool in there. That's not going to hurt anything. I can keep it in there. All right, so interface fast Ethernet 0/1, IP address 190.190.9.25. Okay, so now I should be able to ping switch 2 finally. There we go. And let's go over to router 2. Okay. Okay, so we've just accomplished step 1 and step 2. Configure R3. R3, okay, such that subnets K, L, and X are once again advertised into OSPF. Okay, I'm just going to pull up my OSPF config that I created and just copy and paste that back in there. Okay, let's verify those networks are being advertised. Show IP route OSPF. Great, right there, that is subnet X, otherwise known as loopback 2. So we're good with that. Add a new subnet, subnet Z, to your existing IPv4 subnet plan. This subnet must support 4 hosts. Okay, and actually I've already done that in most of the things I've been showing you up until now. There is, well, this says subnet X. It should really say subnet Z. But right here, this is the new subnet. So this is the next available one, 9.64. And to support 4 hosts, it's got to be a /29. Okay. Add a new VLAN, VLAN 6 to all 3 switches. This new VLAN will be mapped to subnet Z. Okay, so let's add VLAN 6 to our switches. So currently switch 3 is a VTP server. At least it should be. Yep. So VLAN 6. And let's go to our VTP transparent switch, which is switch 2. Yep. And let's go to our VTP client and make sure that he has learned of that VLAN. And he did, VLAN 6. All right, great. Assign the second and third host addresses from subnet Z to these interfaces. All right, so I'll go ahead and do that. So let's see here, let's go on to switch 2. Interface VLAN 6, IP address 190.190.9. Okay, we're supposed to give him the second address, so 64 is the subnet, so 65 is the first, 66 is the second. And this guy here is supposed to get the third, which will be 67. Okay, let's make sure they can ping each other. Very good. All right. So we've done 6 now. Now number 7, configure switch 3 as a DHCP server such that it will advertise host address number 1 in subnet Z as the default router address. It will do a lease time of 7 days and 12 hours. It will exclude the addresses statically assigned to switch 3's SVI 6 and R4. Shouldn't say R4. 1 second, because R4 is not participating in this. So it will exclude the addresses statically assigned to switch 3's and switch 2's SVI6. It will allocate all remaining host addresses. Okay, so let's go ahead and configure that guy as a DHCP server. IP DHCP pool, we'll just call it Cisco. Network is going to be 190.199.64/29. Default router is going to be the first host address in this network. Okay, lease is going to be 7 days and 12 hours. Okay, exit IP DHCP exclude -address. The second address and the third address. Okay, so this right here this completes that task. We've just created that DHCP pool in switch 3. We're still in the pre-HSRP stage. Okay, on switch 3 and switch 2 only, add subnet Z to the OSPF process. Easy enough. Okay, so we've added it to the OSPF process, keeping it in area 0. Create interface, so we're going to create a sub-interface on R2 and configure it to obtain its IP address via DHCP. All right. Interface fast Ethernet 00.6. That's going to be encapsulation .1Q6. IP address DHCP. Now, one thing I'm wondering about is I seem to recall from way back when we configured all these VLANs and trunks in the first place, I think, and we'll verify this, I think that this trunk link, this isn't the right diagram. Come on. Where is the other one? This one right here. I think that this trunk link between switch 1 and router 2, because remember he's broken up into sub-interfaces right here. I think I remember that we configured switch 1 so that he would only allow VLANs 2 and 3 on that trunk. If that's the case, we're now going to have to add VLAN 6 into that so this works. So let's go to switch 1 and just see if I'm right about that. Show run interface fast Ethernet 0/2. Yes. It's only allowing VLANs 2 and 3. Okay, so we need to add VLAN 6 into that. Okay, so now that VLAN 6 is on there, router 2 should be getting an IP address via DHCP on that sub interface. Unassigned. Sometimes it takes a moment. Just lost neighbor switch 3. Not sure what happened there. Still don't have an IP address. Still trying. All right, let's run through this real quickly here, make sure that everything is okay. Oh, my line protocol is bouncing. Fast Ethernet 00 must have gone down and then come back up. Why? Why is that happening? Show run. Oh, can you guys remember why? So I know not all of you were here on the first day. Yes, Dwayne, you figured it out. That's right. Back when we did LAN switching, we put port security right here on this interface, and we limited the amount of MAC addresses it could learn. But now that we've just added a new sub interface right here, we're exceeding that quantity of MAC addresses, and it's causing that 0/2 on switch 1 to bounce, and go up and go down and go up and go down. So that's what we need to fix. Let's shut it down temporarily. And let's bump this up to 4 addresses. So 1 for VLAN 1 and then VLANs 2, 3, and 6. Oh, not 6, 4. All right, I think I still have my debug working here. Show debug. Nope. Show IP interface brief. Oh, there we go. Right there, assigned address. Okay, good. So DHCP is now working, and I now have, uh-oh, that shouldn't be right. It gave me the very first host address, and that's the address allocated for the router. So we need to go back in the DHCP server and exclude that address. Okay, let's go back to router 2, bring down his interface temporarily. Okay, and bring it back up. And wait to see that DHCP message again. Okay, good. This time he got 68. And what's kind of interesting about this is when you do show IP route, look at this. I did not configure this. This is because when he received the address via DHCP, he was also informed the .65 was his default gateway. So he actually installed that as a static default route in his routing table. Pretty nifty. All right, so where were we? Lastly, ensure R2 can ping the IPv4 addresses in subnet Z on switch 2 and switch 3. Okay. Ping. That is switch 2. And that is switch 3. Okay, so now this topology is fully functional. We're finally ready, to add HSRP to all of this. We had to get all this stuff operational first before we could do HSRP. And HSRP. Configure HSRP on switch 2 and switch 3 as follows. HSRP will use the virtual IP address of subnet Z's host address number 1. Switch 2 should be the HSRP active router. And if interface fast Ethernet 0/4 goes down on switch 2, and that is right here. So if that interface goes down, switch 3 should become the new HSRP active router. Okay, so let me ask you some questions here. First of all, what can we do to ensure that switch 2 is the HSRP active router? I mean, even though it's a switch, you get the idea. What can we do to make sure that he becomes active? Well, with HSRP, by default, the active router is the router that has the highest HSRP priority. That's the first thing that's looked at. Do you remember what the default value is for HSRP priority? It's 100. 100. So let's just make him 101. Not sure what happened there. So that's what we'll do. Okay, so here's the configuration I'm going to put on these guys. So on switch 2, I'll go on to interface VLAN 6. And in order to configure HSRP, you use the standby command. Standby, and then you provide it the HSRP group number. You can pretty much pick any number you want as long as all the routers participating in HSRP share the same group so they can talk to each other. So most people usually start with the number 1. Standby 1, and then you say IP, you say, okay, what's the virtual IP address? All the hosts out there, what will they think the default router is? And in this case, it's going to be 190.199.65, the first host address in that subnet. And then in order to make sure that he is the active router, I'll use the standby 1 priority command and give him a priority of 101. And switch 3 is going to be pretty much exactly the same, except I'm going to leave off the priority command and give him the default priority of 100. Okay, so that should accomplish 11A and 11B. Won't do 11C, but I'll do 11A and 11B. So let's go ahead and try it out. So first of all, switch 2. And switch 3. Okay, let's wait for a moment. We should get, if we're logging syslogs to the console, we should get a message from HSRP in just a moment telling us what it's doing. Show logging. Yep, we are logging stuff. Now, while we're waiting, what show command can I execute? There we go. So right there, HSRP state change. On VLAN 6, group number 1 went into the standby state. Now, if somehow I had not seen that, if I missed it, what show command could I issue to confirm that HSRP actually is working on this box and what state he's in, at least on that particular interface? The command we'd be looking for is show standby. And there we go. So for VLAN 6, now if this was a real router, it would say like fast Ethernet 00 or fast Ethernet 11. But I did it on my interface VLAN 6. The interface VLAN 6 has group 1 and my local state is standby. Here's the virtual address, so all the laptops and clients will be thinking that .65 is the default gateway that they should use. When they send Ethernet frames to their default gateway, this is the destination MAC address that they will send it to. And the actual device that's listening to that address that will actually be picking up the frames and routing them on behalf of the group is the active router, which is .66, which is switch 2. Okay, so let's go ahead and test this out. See, what's a good way to test this? I'm wondering because router 2 also has other subnets that he's in. Okay, here's what I'm going to do. Go back to my topology diagram here for a moment. On router 2, what I'm going to do is I'm going to shut down subnet .2 and .3, and I'm going to shut down fast Ethernet 0.1. So the only way he has to get out to the outside world is via VLAN 6 that's running HSRP. And then we'll try it out. Okay, .2, .3, and fast Ethernet 0.1. Okay, so at this point he should have lost all of his OSPF routes because he's not running OSPF across that DHCP interface. So the only route he has is his connected routes and then the default route that was learned via DHCP. So at this point, he should be able to ping 3331, which is router 3's loopback. There it is. Okay. Now we know that switch 2 is the default gateway. So now let's just do a quick test here. Let's open up another session. There we go. And what I'm going to do is I'm going to go on to switch 2. Okay. And what I'm going to do is I'm going to start doing a continuous ping to 3331. We'll do a repeat of 10,000. And then as that ping's going on, I'm going to go into switch 2 and shut down his VLAN 6 interface. And we'll see how long it takes switch 3 to claim the role of HSRP active and how many pings are lost during that process. So here we go. Look at that. Looks like we haven't lost any. Pings are just still going. Now here's a question for you. When I enable switch 2 again, with what I've configured so far, which was this, will switch 2 reclaim the role of HSRP active? That's right. Frank's got it correct. No, he will not. What could I do so that he will reclaim the role of HSRP active? What could I do to force him to take that role back to himself? I would have to configure an HSRP feature called preemption. Preemption. So let's go ahead and add that. So on switch 2, that's simply saying standby 1 preempt. Okay, and now let's bring him back up. There he went active. Still haven't lost any pings. What a great feature. Look at that. How quick. Let's go ahead and stop that ping. 99%. So I'd say it worked pretty well. All right, last step. And then we're done with this feature. Is step 11C. If interface fast Ethernet 0/4 on switch 2 becomes disabled, switch 3 should become the new HSRP active router. All right, so let's just go ahead and work on that. So let's go to switch 2. So in order to make that work, the first thing we have to do is configure something called a track object. A track object is something that is tracking something. In this case, I'm going to have it track an interface. And then other features can refer to that track object, and the track object can say, hey, you're using me, just want you to know this interface that you told me to track, it's down, oh, it's back up. So we're going to create a track object to do that, and that's just the track command. You give it a number, and in this case I'm going to say interface fast Ethernet 0/4, and I want to track the line protocol. Okay, and there's other stuff we can do in here as well, but we don't need it for this. Okay, so that's the first thing. So HSRP is going to be told to monitor this thing. And so track 1 is going to be responsible for telling HSRP what's going on with this interface. Now the next thing I need to do is in HSRP, interface VLAN 6, I say standby 1 track 1. And now I have to tell HSRP, what are you supposed to do when track 1 reports a problem? And I've got a choice here. I could either tell interface VLAN 6, hey, just shut down the whole group. Just remove yourself entirely. Or what I could do is decrement the priority. So right now he's a priority of 101, which is slightly better than the default priority. So why don't I decrement him by 5? So what's going to happen here is that if interface fast Ethernet 0/4 reports that the line protocol has gone down, the track object's job is done at that point. He has reported the information. He's reported the news. Now when standby, when HSRP receives that news, he's going to take his priority of 101 and lower it down to 96. Now, at that point, if the other HSRP router, which in this case is switch 3, if he was configured for preemption, which he's not, he would take over that job. So that's the next step. I need to go into switch 3 and tell him, hey, you're standby right now, but if you detect that the active router all of a sudden has a lower priority than you, take over his job. So that's what we're going to do. Go into switch 3. Interface VLAN 6, standby 1 preempt. Okay, so he's not going to preempt right now. He's not going to do anything right now because he recognizes, he says, look, the active router is not me. See, it says standby router is local. I'm standby right now. And the guy who's active, he's better than me because he's 101. I'm only 100. So now let's see what happens when I shut down that interface on switch 2. interface fast Ethernet 0/4, shutdown. Immediately, see, here's the track object saying, hey, the line protocol just went from up to down. And now HSRP says, okay, I've changed my priority, so let me tell everybody about that. All of a sudden he realizes there's somebody else out there who's got a better priority than him, so he goes from active into standby. So now he's standby. Show standby. So he is no longer active. He is now in standby state. His current priority is 96. And lastly, when I bring that interface back up again, interface fast Ethernet 0/4, we'll see that the track object will report that. And this guy's priority will go back to what it was before, 101. And because he is configured for preemption, says right here, he will once again take over the role of being the HSRP active router. There we go. Tracking state went from down to up. HSRP reclaimed the active role. And that concludes this section on HSRP.